Okay, let's look at the example for mesh current analysis and wrap up, well, hopefully wrap up mesh current analysis after that. So let me quickly switch over. Class notebook right there. Let's see. Okay, so mesh current analysis. Here's a summary slide. First thing you would do is identify the meshes, assign the mesh currents with direction. Then you apply KVL to each mesh, and you express each resistor voltage in terms of the mesh currents, plug in all the known values, and then solve the equation. So the equation, the example problem for mesh current analysis has 3 voltage sources and 4 resistors. How many meshes do we see in the circuit? Just 2, right? There are 3 electrical loops with 2 meshes. And as usual, for my preference, I'm going to choose clockwise direction for my mesh. And because the sources have A, B, C, I'm going to use notations 1, 2, 3. Well, numbers, not 1, 2, 3, just I1 and I2. This is mesh 1. This is mesh 2. Both currents are going clockwise. R1, R3, and R4 are not in a shared mesh. R2 is shared between 1 and 2. Then let's go ahead and apply KVL to our mesh. So mesh 1 and KVL again. My preference is to start at the bottom left corner and go clockwise. Right, so if I start at the bottom left corner and I go clockwise, I have 4 voltages. VA, VR1, VB, and VR2, 0. Resistor voltages are positive. VA is negative. VB is positive. Again, it does not matter how you're going to apply KVL. If you have your own preferred method, feel free to keep using that. Now, apply Ohm's law and express VR1 and VR2 in terms of the mesh currents. So this becomes I1 times R1. And VR2 is a shared branch. We are applying KVL in mesh 1. So this becomes I1 minus I2 times R2 is equal to 0. Okay, it's a shared branch. Mesh currents are hypothetical. And so I1 is going clockwise. I2 is going counterclockwise, going in 2 different directions through R2. 2 voltage drops, I1 minus I2. Plug in all the known values. VA is 10 volts, so minus 10 plus R1 is 5, so 5 times I1 plus 9 plus R2 is 10, so 10 times I1 minus 10 times I2 is equal to 0. Reduce the equation, I get 15 times I1 minus 10 times I2 is equal to 1. I'm going to call this equation 1. Right? Make sense? Again, the critical part is right here. I1 minus I2. Okay. Then for mesh 2, I apply KVL. Now I have 5 voltages. VR2, VB, VR3, VC, VR4 is equal to 0. Resistor voltages are positive. VB is negative. VC is positive. R3 and R4 are not shared. R2 is the only branch that is shared. And so this becomes I2 minus I1 times R2. I2 times R3 plus VC plus I2 times R4 is equal to 0. Plug in all the known values and reduce the expression. R2 is 10. So it's 10 times I2 minus 10 times I1. Minus VB is 9 volts, so minus 9. R3 is 5, so 5 times I2 plus 1 volt plus 5 times I2 is equal to 0. Reduce this expression, and I get minus 10 times I1 plus 15, sorry, not 15, 20 times I2. Minus 9 plus 8 is minus 8. Take it on either side, plus 8. Call this equation 2. Two unknown variables, two equations. Solve them with any method that you choose. You get your answers for I1 and I2. So solving them by hand, I'm going to take equation 1 multiplied by 2. That gives me 30 times I1 minus 20 times I2 is equal to 2. Call this equation 3. 2 plus 3 gives me 20 times I1 is equal to 10. Therefore, I1 is equal to 0.5 amps. Right? Did anyone plug it into your calculator? If anyone did, please verify my answers. And then plug in I1 into any one of the equations above. Let's use equation 2. You get minus 10 times 0.5 plus 20 times I2 is equal to 2. 20 times I2 is equal to 5 minus 5. Wait, sorry, no, this is 8. So this is 13. I2 is 13 divided by 20, 0.65. Did anyone perform the calculation? Same, thank you. 0.65 and 0.5. Okay, questions. Again, the equation, generating the equations is the main part, right? So let's recap. We started at the top where we looked at the circuit diagram. We saw that there were two meshes. Two meshes means two mesh currents, meaning two unknown variables, right? We applied KVL in mesh 1. There are 4 voltages in mesh 1. I usually apply clockwise direction. So when I apply clockwise direction, I have VA as minus plus VR1 plus VB plus VR2. VR2, based on the hypothetical mesh currents, I1 and I2 flowing in the opposite direction, gives me I1 minus I2. When I go to mesh 2, the exact same voltage is now I2 minus I1. Because again, I'm adding up KVL in a clockwise direction. If you choose to add up KVL in a counterclockwise direction, you would still get the exact same equation. So This is the equation we obtained, right? Plus VR2 minus VB plus VR3 plus VC plus VR4. If I add up KVL, if I add up the voltages in this direction, it'll still be the same. Now I would get minus R4 minus IR3 minus IR2 minus VC plus VB, which would be exactly the same equation. So it doesn't really matter which direction you add up the voltages. Okay, you would still get I2 minus I1 at the end. So mesh 1, it's I1 minus I2. Mesh 2, it's I2 minus I1. Second point, look at resistors R3 and R4. What is the relationship between R3 and R4? Well, what's the relationship between R3, VC, and R4? They're all in series. If they're all in series, even though schematically we have drawn them separated, the two resistors are separated by the voltage source, all three components are in series, so it is still possible to combine both resistances in series. So you do not have two separate quantities when you write your equation. And now if you take a look, so if you combine both the resistors together, R3 and R4, 5 plus 5 is 10 ohms. Take a look at the equation. The equation we obtained was 5I2 plus 5I2, 10 times I2. Make sense? So mathematically, it's verifying what we could have done at the beginning. We could have reduced it by combining the two resistors in series, similar to what we did for today's quiz. We had two resistors in series at both ends of the circuit. You combine them together, you are left with how many nodes? Anyone? How many total nodes did you have in today's quiz? 4. If you pick one end of the voltage source as your reference, that's 0. The other end of the voltage source is 10 volts. You're left with 2 unknown variables. That was the hint that I provided in there. You had 2 unknown variables in there. You only needed 2 equations to solve. I'll post the solutions once I have them written out later today. Third point, if you take a look at the circuit and you try to solve it using node voltage analysis, how many nodes do you see in here? Let's count. Top left, 1, 2, 3, bottom node 4, 5, and 6. Any point where two or more components come together is an electrical node. So node voltage analysis, we have 6 total nodes. Even if we choose one end of a voltage source as a reference and we eliminate 2 nodes, you're still left with 4 nodes, meaning 4 unknown variables, meaning you need 4 equations to solve. So both techniques would work. You can solve it using node voltage, you can solve it using mesh current, but mesh current analysis makes the most sense because you only have 2 unknowns. Make sense to everyone? Now it's 11 o'clock, so if you need to leave, that's fine. I'm going to take a couple more minutes and talk about current sources and super mesh. Okay. If you have a current source and you wish to solve using mesh current analysis, it makes sense to choose a mesh current that is in the same direction as your current source. So let's say if you have a circuit like this is current source IS, I would choose a counterclockwise mesh current. Let me call this IA. And so mesh current IA will automatically have value equal to IS. Okay. If it is a shared branch like this, we cannot obviously write a KVL equation. So what we do is we combine both the meshes. So this is M1 and this is M2 with a shared branch. We cannot write a KVL equation because we cannot describe the voltage across that current source. Since we cannot do that, we will combine both meshes together and call it a super mesh. Essentially, all you're doing is you're applying KVL around both the meshes together. That's all. So again, super mesh sounds something like out of a Maurel technique, but it's not. You're simply applying KVL around both meshes. The only thing you have to keep in mind is the mesh currents still apply. Meaning if I apply KVL here, I would get 1 times I1 plus 2 times I1 minus I3 plus 4 times I2 minus I3 plus 10 is equal to 0. You still have to take into account that left side has I1 and right side has I2. Okay, so you apply KVL around that big outer loop of both the meshes, but the two individual mesh currents are still the ones that are causing the voltage drop. Okay, so super mesh, if you have a current source somewhere in there, you simply take the two meshes on either side of the current mesh, of the current source, and you apply KVL around that loop. So regular KVL, that's all you're doing. But the thing to keep in mind is that even though you have two separate meshes, even though you're combining the two meshes together, the currents are still different, I1 and I2, either meshes. You can also write one more equation in terms of the 5 amp current source. So 5 is equal to I2 minus I1. Okay, I2 minus I1. So similar to the previous problem where R2 was a shared branch, it had I1 and I2 flowing at the same time. We can consider that the two mesh currents and I1 and I2 result in the current source 5 amps. And so if I2 is going up in the same direction as the current source, I can write 5 is equal to I2 minus I1. Now, we rush through this a little bit. So review the slide, review the video. I'll post it later as soon as I get to my office. We may end class here today. If you have any questions, I will be in my office for office hours and also available via Zoom and email. All right, so let's stop recording right here.